Hi, in this video I am going to talk about contamination. Contamination in fermentation industry. We all know what is contamination is. It is a growth of foreign unwanted microorganism in our culture. So in case of fermentation, this foreign unwanted organism is growing in our media during the fermentation process. So contamination has so many negative effects in fermentation. These are the some of the negative effects I listed here. First one is loss of productivity. So we have optimized a medium for the growth of our microorganism. We have optimized the media components as well as the physical conditions for the growth of our microorganism, which is producing a useful product. Then, if a contamination came, the contaminating organism is consuming all our nutrients. So what happens? There will be a competition between these producing organism and the contaminating organism. The contaminating organism will use the some of the carbon sources, nitrogen sources, and everything. And what happens is like the amount of product produced by the producing bacteria will reduce. So there will be a loss of productivity, the yield will be reduced, the economic benefit of the process is also reduced. Then destruction of producing organism, it is especially true when it is contaminated by a bacteriophage or other type of virus against a fungus or something like that. If a bacteriophage came to a fermentation done by a bacteria, what happens? It will kill the bacteria. So number of producing bacteria will reduce. Or sometimes it will just inhibit. Suppose if we have a bacterial fermentation and it is contaminated by a fungus which is able to produce antibiotic, it will inhibit the growth of our bacteria. So net effect, the productivity won't be there, the yield will be reduced. Then if a contamination happens to the continuous process, it will displace the producing organism. Especially true when we are running a continuous culture and we got a contamination by an organism which has a higher growth rate than our producing bacteria organism. What happens? In long run, it will replace the producer. In the continuous culture, all of the producer will be replaced with the contaminating organism. That can happen in continuous culture. It alters the environmental conditions as the contaminating organism may be producing an acid or degrading a acid in the medium. So if they do something like that, the physical conditions can change. It can consume a lot of oxygen, which make the dissolved oxygen levels change. So it will alter the physical environment, which in turn affect the growth and the product formation of the producing organism. Then it can cause product contamination. Some of this contaminating organism is able to produce some byproducts or toxins which may be carry over to the product, and the contaminated product will be contaminated with this byproducts by the contaminating organism, which is not desired in industry. Difficulty in downstream processing. Sometimes the products produced by the contaminating organism and our desired product may have the similar physiochemical properties. In those cases, we need to do extra steps to separate these two. So it complicates downstream processing. In some cases, we cannot do that. We cannot separate the contaminating product, the product produced by the contaminating organism, and our desired product. In those cases, we need to just throw out the whole thing, and throwing out something is more expensive because we have invested so many time, energy, and money to start a fermentation. And if you are throwing out, you cannot just throw it away. You need to do the wastewater treatment process to make it acceptable for the environment. Other thing is product degradation. Sometimes the contaminating organism can degrade our product into other compounds, or it can transform it into some of the useless compound. So that can also happen. It will, all of these situations invariably cause loss of yield. The yield will be reduced or there won't be any yield. This will lead to a economical crisis because the fermentation will become economically unviable. So we need to do so many things. We are doing so many things to prevent contamination in bioprocess industry. So the effect of contamination differ depending on the process. Sometimes some type of contamination cause specific effects. Other type of contamination cause different effects. If you say if you look at some of the example, this Pedococcus damonis, which cause soreness in beer. It used to contaminate the brewing process. The brewing process, if this Pedococcus came, and it will cause soreness in the beer. The taste of the beer will be changed, and which will make it unacceptable. We cannot sell it because the taste awful. So in other case, sometimes the penicillin producing fermentation, the bacillus species can be a contaminant. If bacillus came in, what they do, they produce an enzyme called penicillinase, which is actually degrading penicillin. So in one end, the fungus is producing penicillin, and the contaminating bacteria is actually degrading penicillin. And because of this degradation, the yield will be reduced dramatically. Especially the bacillus has a higher growth rate than the penicillium. So it is a very difficult contamination. One of the other contamination, specific contamination, is that the contamination by the acetobacter. Acetobacter is the organism which convert ethanol into acetic acid. If that contamination occurs in an alcoholic fermentation, the alcohol will be converted into acetic acid, which is actually vinegar. But if you have set up a fermentation for alcohol fermentation, if it is, some of it is converted to acetic acid, the whole thing will become unconsumable. You cannot sell it, you need to throw it away. So the effect of each type of contamination is different. So there are specific effects, specific effects of contamination, and there is also generalized effect of fermentation contamination. Any contamination occurs, there will be a loss in yield, that's for sure. But there are also some specific type of effects by specific type of contamination by the other microorganism. So how to avoid contamination, which is very essential and very central to the bioprocess industry. So there are different methods, different practices we are doing to avoid contamination in bioprocess industry. These are the main practices. First thing, the inoculum should be pure. The inoculum, the organism we are going to use in the fermentation, should be pure. If the inoculum is contaminated, you will get contamination in every place. So to make sure that the inoculum is pure, what's a pure inoculum? The pure inoculum contain only specific type of organism. It should not contain any other type of undesired organism. It should not contain any viruses. So we always use the pure inoculum. That's one strategy. Secondly, we should use sterile media. The media components should be sterilized. You know how to sterilize something. You can put it in the autoclave, and after 50 minutes at a 121 degrees Celsius, it is sterile. But the thing is that in industry, we are using huge volumes, maybe 10,000 liters or 1 lakh liters. Sterilizing this much volume of media is very expensive, and some of the fermentation not need pure sterile conditions. So depending on the need of fermentation, we need to sterilize the media. You may be a little bit confused by the sterilization of media in industry and laboratory. I'll explain it later. There is a difference in term when we use it in industry and in laboratory. So we should use sterilized media. So contaminating organism should come from the media. Then sterile equipments. The equipments what we are using, the fermenter, the tubings, the probes which we use to measure the different physiochemical conditions, the feed, everything should be sterilized. So sterile feed should be used. Sometimes we are adding some of the metabolic regulators as feed. So those feeds should be sterilized. Sterile air, we are giving continuous aeration to the fermenter, so we should make sure that the air what we are giving should not have any microorganism. If the air has microorganism, it may act as a contaminant, it will spoil our product. And we are supposed to maintain aseptic conditions. We know how to behave in a microbiology lab. We should be wearing the coats, we should be maybe wearing the mask, we should wipe our hands with the alcohol. So such type of industrial practices are there. So all the workers are supposed to do the aseptic practices to avoid contamination to the fermentation. So these are the general practices. In this session, we are basically looking at how to sterilize the media. Okay, before that, some of the fermentations are termed as protected fermentation. As I said before, there is a difference between sterilization in laboratory and sterilization in industry. When we say sterilization in laboratory, it means no single living organism should not be there. So all the living organism, including bacteria, virus, fungus, spores, everything should be wiped out. There should be, if we want to say one medium is sterile in laboratory, it should not contain any living organism or its spores. So that's a very stringent condition. But in industry, as I said before, we are using huge volumes of medium and huge volumes of everything. So it is practically impossible for some fermentation to sterilize this media. If you have 1 lakh liter of something, how do you sterilize it? How much energy it will cost, and how much time it will need to be get heated up. If you are 1 lakh liter, you cannot heat it up very easily. Or how much time it will take to cool down. Maybe it will take weeks to get to the room temperature. But the thing is that in industry, sterility mean something different. In an industrial medium, when we do sterilization, we don't kill all the living microorganisms. We remove only the organism which potentially cause contamination. So in laboratory, we are giving a different explanation. In laboratory, when we say sterilization, it should not contain any living organism or its spores. But in industry, sterilization is means it should not containing any potential contaminating organism. We don't have to kill all the possible microorganisms, especially in case of protected fermentation. Protected fermentations are fermentations which has an ability to resist contamination. Let me give you an example. When we make curd in our house, it's a fermentation. It's a fermentation done by lactobacillus in milk. Do we keep everything sterile? Are you sure the inoculum you are using, the previous curd, is only containing lactobacilli? Is it a pure inoculum? Most probably not. It may have another type of microorganism. Or the milk you are using, maybe you are just heating it up, but it is not a sterilization technique. You are not even pasteurizing it. You are just boiling it, just for maybe 1 minute or something like that. That does not kill all the microorganism, and it definitely not kill spores. So your medium, the milk, is not sterile, and the inoculation, the process adding the milk with the previous curd, are you doing it in the laminar airflow with all the protective equipments? No, we are not doing like that, and we are not doing this fermentation in airtight containers or something like that. So we are not keeping anything very stringently. We are not keeping any protocols for preventing contamination. But how many times you face the difficulty of contamination? You're seen a contamination in milk making, the curd making. This is very rare. Only if there is a contamination in the milk you are using, it may contaminate the curd. Otherwise, it won't happen. So, why it is why contamination is not happening to the curd? The thing is that it's a protected fermentation. Lactobacilli is the best organism which grows in milk. No organism usually seen in our environment can outgrow the lactobacilli. The phase of growth is so high, it can utilize lactic acid and everything, all milk components very efficiently. Further, it will lower the pH. Once the lactobacilli grow in milk, it will lower the pH because of the lactic acid, and it will coagulate milk proteins, and no other organism is able to outgrow the lactobacilli. That's a protected fermentation. Even if you are not keeping any stringent conditions for controlling the contamination, the fermentation will be totally fine. So those type of fermentation is called protected fermentation. The wine making, we are not sterilizing the grapes. We are just snooze it out and maybe just heat it up a little bit in some cases, and we are adding yeast because yeast is the best organism which can grow in the grape juice. So, and we are mixing it in every day for 1 or 2 weeks. So we are not opening it in the laminar air hood or something like that. So still the fermentation is totally fine because these are the protected fermentation. This fermentation has a resistance against the contamination. So the protection fermentation, the degree of protection will vary depending on the type of fermentation process, duration of fermentation. If it's a short fermentation, it maybe most of the fermentation will be protected. But if you are running the fermentation for a long time, maybe 2 months or 3 months, some microorganism can get in. The chance of contamination will be high. Type and magnitude of possible contamination: when we are using milk as a uh, as a medium, the milk is basically, if you have handled it very nicely, we are using keeping all the containers clean, it is basically the microbial load is very less. The milk which is we are getting from the cow is basically sterile, and only contamination in there because of the environment and handling. So the number of contaminating bacteria and my other microorganisms will be less. So the type and magnitude of possible contamination is depending on the type of source material from we where we get the medium. So that's also different in the case of protective fermentation and probability of contamination. If the probability of contamination is high, the protection will be less. And nature of its consequences. What happens if there is a contamination? Even there is a small contamination in your milk, which you are using for the curd, nothing will happen because the lactobacilli will outgrow and it will kill all other microorganisms with its acid and everything. So the consequences of contamination is also important in determining the protected fermentation. So in industry, we have protected fermentations and non-protected fermentation. For the protected fermentation, you don't have to sterilize everything. You can just make basic uh, steps to avoid contamination. But if your fermentation is unprotected, especially if you are making a antibiotic or other pharmaceutical, or you are culturing a animal cell culture, those all are very unprotected fermentations. You need to keep everything sterile. If you are culturing some genetically modified organism, everything should be sterile. If you are culturing an animal or plant cells, sterility should be at the maximum. You cannot compromise. But if you are making a curd, or if you are making a kefir, or if you are making some other fermented products, so it's okay. That's all protected fermentation. The microorganism will grow very nicely, so no other microorganism will be able to get in. And there are different methods for sterilization. If you are doing a fermentation, there are different methods to sterilize. Those are divided into physical methods and chemical methods. Physical methods including asepsis, filtration, heat, radiation, and ultrasonic treatment. Chemical methods are the chemosterilants and gaseous sterilants. I will be explaining most of these methods in following videos. In this video, I am going to talk about asepsis. Asepsis is generally maintaining general cleanliness in the workplace. So we are keeping everything clean, just like what we are doing in our microbiology laboratories or with the laminar hood. We'll be keeping everything clean. We'll be having a lab coat, and sometimes we'll wear a mask and gloves or other protective measures, and we will be wiping it with alcohol. We are not keeping things in the laminar hood, and we are sterilizing the everything. We might be washing our hands. You know the general laboratory guidelines. You should not eat, you should not smoke, you should not drink. Things like that should not be done in the industry. So that's a part of asepsis. It is especially important in the protected fermentation. Even if the fermentation is protected, if you are doing things like that along with the fermentation, it may cause severe harm. We are if you are making a curd or with 200 milli of milk or 1 liter of milk, it's okay. But if you are doing it in an industrial scale, a contamination will cost you too much. So in order to prevent that, general cleanliness should be maintained. And the pipes, fermenter voids and floors are washed with the disinfectant. If you are going to some ISO 9000 company or something like ISI company, they will be wiping the floors continuously with the disinfectant to avoid contamination. Incoming air can be sterilized so that the contamination from the air can be avoided. Asepsis generally helps to reduce the microbial load. If you are using general cleanliness and behavior, it will reduce the microbial load, so the chance of contamination will be less. It will lessen the stringency of sterility measures. So if you are keeping everything clean, you don't have to sterilize much. So the cost of sterilization is much. So the mild techniques can be used for the sterility, and it also remove focal of microbial growth. If some fermenter, some place of fermenter, if there is a focal of microbial contaminant growth, it may contaminate all batches of process. So if you are wiping, cleaning and everything the fermenter every time, the focal growth will be lost. So otherwise the focal will grow, act as a source of contamination. So such things should be avoided. So asepsis is a general practice, we that what we should do in an industry to avoid contamination. It is not a sterilization technique, so it's a way of avoiding contamination. And most of the fermentation industry keep these aseptic techniques to avoid, to lessen the contamination. Thank you so much.